Hello and welcome to IGCSE Tube. So this is part number 6 of chapter number 14, organic chemistry. Sorry, let me get the highlighter, the yellow. Alright, so in this video, I will be introducing what is meant by alkenes, E-N-E, we talked about alkanes, now we're going to talk about the second type of hydrocarbons, which is alkenes. So this is a screenshot from the syllabus. This is the Cambridge IGCSE Chemistry syllabus for examination of 2016, 17, and 18. I always link the syllabus in the description box below, so go ahead and give it like a look and check it out if you haven't. Alright, so in section number 14.5 it says describe the manufacture of alkenes and of hydrogen by cracking. Now, I need to say that this is the third reaction of alkanes that I have mentioned in part number 4. So we talked about substitution reaction, we talked about the combustion of alkanes, and the third type of reaction is cracking. Now, cracking involves the understanding of alkenes. That's why I'm starting by introducing alkenes and then going back to the cracking. I think I'll do the cracking in part number 7 just because I want to keep the length of the video minimal. Alright, let's start with the alkenes. So alkenes are defined as unsaturated hydrocarbons. In other words, they have double covalent bonds between two carbon atoms, C double bond C. So if you recall, alkanes are saturated, not unsaturated, because they have single bonds, whereas alkenes, they have double covalent bonds between two carbon atoms. Therefore, the functional group is ene and not ane, and or C double bond C. Whereas for the alkanes, if you've watched the video, it is it's still on the highlighter mode. I'm sorry. It is ane and C double bond C. Single bond. Now, for the general formula, it is CnH2n, where n is greater than or equal to. For the alkanes, it was CnH2n plus 2. Here, there is no the plus 2. The plus 2 does not exist here. And the n is greater than or equal to, meaning in the alkanes, it was n greater than or equal 1. So when you put 1, it was called methane. You won't have here something known as methane, for example. No, it starts with ethane. It starts with n greater than or equal to. Okay, since alkenes have a functional group and they have a general formula, they form a homologous series. And we already talked about what is meant by a homologous series, I think in part 1 or 2. I'll link it as well in the description box below. Okay, quick recall. A homologous series has the following characteristics. 4 characteristics, very simple and easy to remember. The same functional group, the same general formula, same chemical properties, but different physical properties. Alright, now let's look at some of the alkenes, their molecular formula, their name, their state, and the structure. Okay, so as we said, N starts from N greater than or equal to, so we start with number 2, so it will be C2H4. Just 2 times the 2 gives you a 4. The math is really easy for that. And the name is ethene. Again, the same naming applies for alkenes, except you just change the ane with an ene. The state is gas, it's not a liquid, and the structure is, so how to draw the structure? So you have 2 carbon atoms. You start off by putting the 2 carbon atoms and the double bond. And then, as you know, a carbon atom is in group 4, and it has only 4 valence electrons, and so it needs other 4 bonds to, it can like bond with the other it can bond with another 4 electrons. So already 2, it has 2 bonds here, so it needs 2 more bonds. So you put 2 hydrogens, and same applies for this carbon atom. So when you count, it should balance 1, 2, 3, 4. That's correct, and 2 carbon atoms. Now we go for N equals 3, so you have C3H6. It's called propane, as well as a gas. So as I said again, you start off by drawing 3 carbon atoms, and then you add the double bonds. You can add it either here or here. It won't make a difference. Okay, so you added it here. Now it has 2. This needs 2 more hydrogen, so you add the 2 hydrogen atoms. When you look at this carbon atom, it has 2 here and 1 here, so it's 3. So it only needs an extra one. Don't make a mistake and add 1 here, simply because carbon atoms can only have 4 extra bonds. For this carbon atom, it has only 1 single bond, and so you can add 3 more. Let me get the highlighter. Okay, so it can have 3 hydrogen atoms. Now when you count 1, 2, 3, 4, 5, 6, yes, that's balanced. Always check yourself. It's very easy to check if you're on the right track or not. Next is butane, which means 4 carbon atoms. Now, isomerism. It's a topic that I keep bringing up continuously, and it's a topic that will continue to show up in organic chemistry. So if you haven't watched the video, like the series of videos that I talked about isomerism, I'll link them in the description box below. So isomerism in alkenes start when n is greater than or equal 4. In alkanes, it started from n greater than or equal 3. So in alkanes, isomerism occurred, for example, when there was a substitution, there was a chlorine or like a bromine added, or for example, if there was branching. Sorry, let me get the pen. So for example, remember in alkanes, so it was like C, and then here all these are hydrogen, and for example you put a chlorine here, so it will be like 1 chloropropane. Or for example, when you had branching, so if it was this and then you add here, let me see, 1. Okay, so here it is. No, actually, let me take that back. In alkanes, because if you add like a chlorine, it can also happen if there are only 2 carbon atoms. Like it could be a chlorine and then just an H and H, so it could be like chloroethane. So I take that back, that isomerism and alkanes start from n greater than or equal 3. Sorry, let me clean up. And there's also another type of isomerism, is that when there's branching in alkanes. So let me just do something and count here. So this will be, if there's an H, so 1, 2, 3, 4, 5, 6, 7, 8. So C2H8. No, C3. Yeah, that's correct. So yeah, in alkanes, isomerism also for the branching type, it starts from n greater than or equal 2. So no. In alkanes, isomerism for the branching starts from n greater than or equal 3. I'm sorry about that, because if you go back and watch the video, this carbon atom can be simply put here, and so it's not considered an isomer. It's considered if it starts from n greater than or equal 4. I'm sorry, just like alkenes. The branching kind, not the substitution kind. Anyways, I'm sorry if I confused you here, but go back to the alkanes video, and I'm pretty sure isomerism also starts n greater than or equal 4 for the branching kind. Anyway, so here the double bond is what makes isomers, because the double bond can be put between the first and the second, so it's called but1-ene, or it can be put between the second and the third. It will be called but2-ene. Again, if you put it here instead of here, it will still be called but1-ene, and if you put it here instead of here, it will still be called but2-ene. Not but3-ene or anything like that. So yeah, I'm sorry about that confusion about alkanes, but alkanes as well, the isomerism starts from n, the branching kind starts from n greater than or equal 4. And as for the substitution, like with a chlorine or a bromine, a halogen that I have discussed in the previous video, it can start from like n greater than 2, n equal to or greater than 2. Okay, so this is called cyclobutane. Now, this is not really required in the syllabus, but the reason I'm mentioning it, because sometimes they get you in the MCQ questions, which are the multiple choice questions, they get you this like weird looking compound, and you ask yourself, and they ask you like, what type of a hydrocarbon is this compound? So the first thing that you should do is basically count the number of carbons and hydrogens. So when you count here, it's 1, 2, 3, 4. So it's 4. And then H, because you might be tempted, oh, there are no double bonds. No double bonds, you'll be tempted to say it's an alkane. But let's count the hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. And every carbon has four bonds around it. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So there's nothing wrong with the compound as far as like the bonding. So no double bonds. You'll be tempted to say, oh, it's an alkane. But no, when you look at the formula, you realize it follows the CnH2n. 4 times 2, it gives you an 8. So it is an alkene, and it is called cyclobutane in this case for the 4 carbon atoms. You're not required to know what compounds are, but just know that if you get an MCQ question that asks what type of hydrocarbon it is, you need to count the number of carbon atoms and the hydrogen atoms and see what general formula it is following, and based on that make your decision. Alright, so I'm going to end the video here. Thank you very much for watching and for all the kind comments you always leave in the comment section below. If you have any questions, please don't hesitate to ask. If you haven't subscribed yet to my channel, please subscribe, and please let your friends know about this channel so that more people can benefit from it. Thank you for watching, and see you in the next video.